Today's problem is find length of loop. Difficulty is medium. Let's see. Given the head of a linked list, determine whether the list contains a loop, sometimes called a cycle. If a loop is present, return the number of nodes in the loop. Otherwise, return 0. Okay. And it goes into internally. They have a. You know what? Internally, there's an extra parameter that we don't get as part of the method, but they use it to grade your result. Okay. Let's see examples. This first list, it does have a loop, and there's 4 nodes in the loop, so output is 4. This contains a loop. Again, this POS, position, equals 3. They pass that into the grader. So the grader is able to say, oh, okay, so the loop comes back to node 2. So based on that, length of the list, I can figure out what the answer should be. All right, this one, this is a perfectly good list. There's a null pointer at the end, there's no loop. All right, number of nodes. Between 1 and 10 to the 5th, 100,000. The data, that's really not important, but it goes between 1 and 10 to the 4th. The position parameter between 0 number of nodes. Linear complexity, auxiliary space, O of 1. Company tags, I've heard of all those companies. Topic tags, nothing very helpful there. Okay, so this is kind of a common interview question. I mean, there's a little bit of a add-on here in finding the length of the loop. Usually the question is there, find whether a cycle exists in the linked list. I've seen that question asked even when there was no intention of writing code, but just, how would you find a cycle in a linked list? Okay, well, there's something called Floyd's cycle detection algorithm. You don't really need to know that, but what you need to know is fast and slow pointers. Okay, so you have 2 pointers, fast and slow. The fast pointer advances 2 nodes every iteration. The slow pointer advances 1 node every iteration. Now, if the fast pointer gets to the last node in the list or the null pointer at the end of the list, then obviously there is no cycle. If the fast and slow pointers meet at some point, there is a cycle. Okay. Now, as far as finding the length of the loop, well, if the fast and slow pointers meet, then they're meeting at some point in the cycle. So we can just run one iteration around the loop and find how many nodes are in it. How would that work? Yeah, we can do a quick example here on this first one. We'll have a fast pointer and a slow pointer. Now, initially, they are both going to point to the head of the list. Fast pointer will advance 2, so that is 3. Slow pointer will advance 1, so it goes to 2. Fast pointer will advance to 5. Slow pointer will advance to 3. Now let's see, 5 through, so this is just going to keep going back and forth from 5 to 3. That's going to go to 3. That's going to go to 4. That's going to go to 5. That is also going to go to 5. And at that point, we have a meeting point, which we can use to iterate through the loop. Okay, so how does that work? We'll start out with an edge case here. That is a 1. Move that over. That is a 1 node list, which obviously can't have a cycle. Just return 0. Set the pointers. All right. While the fast pointer has not found the end of the list, we are going to, oh, wait a minute, I had a debugging line in there. Let's see, slow will advance 1 node, fast will advance 2 nodes. If slow equals fast, then we'll do something. If they don't equal, we'll just keep going. Advance the fast 2, advance the slow 1. Again, if at some point the fast gets to the end of the list, we drop out of the while loop and return 0. If at some point they meet, then we can set the meeting point node. We can set a counter, and we can iterate around the loop until the pointer comes back to where it started, and that is our loop count. So let me actually, let's get rid of the writing. Let me submit this kind of a sanity check. That seems okay. And we're going to go to, let's submit it. All right, that's it. It's Floyd's cycle detection algorithm. Fast pointer, slow pointer, and if you want to, after determining that there is a cycle, it's a pretty simple matter to iterate, to run a loop around the cycle and count the nodes. So that's it. Please like the video. You can subscribe to the channel. It's free, and we'll see you next time.